Today we are going to talk about something mind-blowing, and the topic is how hydrogen is transforming pellet expansion in blast furnaces. So buckle up because this is going to change the way we think about iron production. So let's jump in. So as we can see the big picture, inside a blast furnace, iron ore pellet are undergoing a dramatic transformation. Hydrogen enrichment is shaking things up, tweaking the pellet's microstructure, altering lattice transformation, and even taming those wild iron whiskers. And it's tackling carbon deposition tool. This is not just science, it's a revolution in how we make steel. Now, coming to key factors behind pellet expansion, and in the process we are going to discover that, so what makes pellet expand in the first place. It's all about the chaos happening inside those teeny iron ore pellets, from gas pressure buildup to a structural shift. There are some key players at work. Stick with me as we uncover the secrets behind this phenomenon. Now, the most important thing is the mechanism of pellet expansion that need to be uh, understood by this content of the slide. Here, where things get wild, pellet expansion kicks off when iron oxide like Fe2O3 transform into Fe3O4 and FeO. These changes create internal gas pressure. As we know, it is very obvious reasons happening, uh, and a lot of volume expansion also occurred. And these making the pellet swell like balloon. Plus, iron whisker form pushing grain apart and amplifying the expansion. This is how the expansion get magnified, and it's like a mini explosion inside the pellet. Now, the question arises here, before going ahead, we must have to introspect. What is the reduction mechanism when a pellet come across CO and hydrogen? Both reduction are bit different. So let's break it down with CO. we can we can get catastrophic expansion up to 224%. 224%. So thanks to slow reduction and crazy iron whiskers growth. But hydrogen, it's a game changer. It slashes expansion to just 24% at 900 degrees centigrade with minimal whisker. So hydrogen is the superhero of smoother steel production, we can say. Now, temperature and carbon deposition. Here, where hydrogen shines even brighter, as temperature rise, hydrogen makes the reduction process faster and cleaner. Less carbon get stuck inside the pellet, reducing the risk of rupture. Plus, it boosts gas permeability, making furnace operations smoother than ever. Hydrogen is rewriting the rules now. Now, why pellet expand? So let's zoom it on the why. Pellet expansion happens because of internal gas pressure and structural shift during reduction. As Fe2O3 transform into lower oxide, gaps and stresses form, causing the pellet to swell. It's like the pellet is flexing its muscle under pressure. So hydrogen superpowers. Hydrogen is MVP here. First, it reduces iron oxide super fast, creating water vapor that escape quickly, lowering gas pressure. Second, it keeps those pesky iron whisker in check, reducing expansion. And third, it shifts carbon deposition to the surface, preventing cracks. Hydrogen is the ultimate pellet protector. Now, hydrogen at different temperature, how it behaves. Here is the kicker. Hydrogen's magic depends on temperature. At lower temperature, you might see a bit of whisker action, causing slight expansion. But crank up the heat and hydrogen's rapid reaction create denser, stronger pellets with minimal expansion. It's like hydrogen turns pellet into a steel superstar. Hydrogen's is, let's hit this again because it's that important. Hydrogen keeps expansion low even at high temperature by reducing viscous and gas pressure. The result, stronger, denser pellets that make steel production more efficient. Hydrogen isn't just better, it's a game changer. So, carbon monoxide versus hydrogen showdown, as it shows the ultimate CO causes massive 224% expansion with slow reduction, and whisker overload hydrogen. It keeps things tight at just 24% expansion thanks to its lightning fast reduction and minimal whiskers. Hydrogen wins the battle hand over. So summing up, hydrogen benefits, let's wrap it up. Hydrogen reduces iron oxide quickly, cuts down on gas pressure, prevent excessive whisker formation and stop carbon form from raking pellets. The result, stronger pellets, smoother operation and a brighter future for steel making. So hydrogen is the hero we need. So the future of blast furnaces have to take a huge big conclusions, or we can say big takeaway. Hydrogen enrichment revolutionizing the blast furnaces. It slashes pellet expansion, boosts efficiency and improve furnace performance. But to make it work on an industrial scale, we need the perfect hydrogen ratio and conditions. The future of steel is green, clean and hydrogen powered. Thanks for watching.